Welcome to the DNA clustering instructional workshop. My name is Jordan Brunson. What we're going to do is walk through some brief examples and a case study on how to group your matches in a way that expands your genealogy, your genetic genealogy research, and makes the most use of any results that you've gotten from taking a consumer DNA test. So some of the parts of what we'll cover will include DNA match relationships, so understanding the amount of DNA that you share with a match and how that relationship might be described. LEEDS method, which is a prescribed way of grouping your DNA matches. Active clustering, so the way that we over time group our matches in a way that makes sense and helps our research. And then also what to do after you've clustered. So why would you consider clustering your DNA matches? So some examples of why you might do that are if you're adopted or have unknown parentage or an unknown grandparent, clustering your matches can help identify the different surnames and ancestors on particular lines within your tree. And also generally helps you go back further. So really wherever you are in your research, you can use grouping through clustering your DNA matches as a way to expand your research and collaborate with others. It also helps you just organize that list. If you've just taken a DNA test, for example, and you've gone to the DNA match list or the list of your relatives, it can be a lot to look at. It's a lot of information thrown at you. So clustering your matches is an easy way to make sense of all the information you're getting provided. Also, it can help if you've been researching and have a significant paper trail or something that you want to find support for. You can find that often in your DNA matches and the people that you relate to through those ancestors you've identified. Also, it just helps you connect with others. And in doing that, you often are in a position to, of course, learn yourself, but sometimes help others who may have information that you don't have information that you have. So clustering, I know I've used the word a few times now, clustering is the process of grouping and labeling your DNA matches into not so neat groups which represent your different ancestral lines. So basically we're putting this long list of people that you're related to into different buckets based on how they connect to you. And we'll eventually get to a visual for how that appears. So there are a few different ways that you can cluster your matches, a few different approaches to it. What we'll use today is a combination of some of these methods. So the first is LEEDS, which is a method created by Dana LEEDS, where basically we're trying to identify your grandparent lines by grouping your matches between 400 centimorgans and 90 centimorgans. And so we'll get into that a little bit later. Also, there's color coding. So if you've taken a test with AncestryDNA, for example, color coding is the grouping method that they prescribe. It makes it very visual and easy to keep track of who is in a certain bucket. And then there's also auto clustering. So sites like GEDmatch, MyHeritage, and other third-party tools will have an auto clustering tool, which often visualizes the groups of matches that you have based on how they're connected, based on your shared matches, essentially. And so what we're going to focus on today is a combination of methods 1 and 2. But before we get into that, a few disclaimers that can complicate the process or make it a little bit more tedious to understand. One example is if in your lineage, especially more recently, if there's any intermarrying. So this would be, there's a few examples. One is through if you have maybe a great grandparent who had children with one of their distant or even close relatives, which ends up creating multiple kinships. And that can make discerning the different groups that you're creating in this process a little bit more difficult to tease out and understand where the relationships are actually coming from, because there are several kind of cross relationships on one line. So that can be something that complicates the process of understanding your clustering. Another example is if you don't have a lot of close matches. So this method, particularly LEEDS, relies on your second to third cousins. And, in some cases, maybe you have plenty of second and third cousins, but they just haven't tested, or at least not where you've tested. And so that will limit some of the information that you're getting and require you to do a little bit more work to understand some of your more recent relative lines. Also, if you have done a lot of research using records over time, or maybe it's oral history, and the DNA evidence or results aren't really corroborating with the research you've done, and you're not really willing to waver or question the research you've done, then you might not be able to fully harness the results and insights that you're getting from your DNA results. Finally, DNA is another example. This is not an exhaustive list, but endogamy is the process of intermarrying over many generations. So the key word there is that it's a practice. So it's happening over a long length of time. And this can really make it basically impossible, if it's significant, to understand where some of these connections are coming from, because there's multiple compounded connections on the same lines. So those are just some examples to consider, and maybe why, if you're clustering your matches and not getting the insights that you feel you're supposed to, this could be one of these examples could be why. And then before we start, I just have a quick quote just to counteract what we just reviewed. So the quote is from James Baldwin. It says, "Those who can't say it can't be done are usually interrupted by those doing it." So one, I understand that this research and the process of clustering your matches, understanding DNA, can be a challenging one. And this is just to say that sometimes you just have to put forth the effort to do it. And that's why this particular session is a workshop. It's one that you can follow along, hopefully. And as we're reviewing this case study, you can apply what we're doing to your matches in real time and, interrupt any notion that you can't understand or do what we're doing here. So without further ado, we have a cluster case study. And so I mentioned that we would review some DNA relationships. This is a table that is hosted on Blaine Bettinger's website. It's the Shared CM project. It just sort of explains and provides context for certain relationships that you would have based on the amount of DNA that you share with someone. So if you look closely at the table, you'll see a range of numbers, and that's for centimorgans, which is basically the unit of measurement that we count DNA or shared DNA for these purposes. We won't dive into a real scientific definition, and I think we're going to clarify that really quick too. So the case study revolves around two siblings. So it's Tina and her full brother, Brian, who have DNA tested because they actually weren't sure whether they were full or half siblings. So they wanted to discover who their biological parents are. They've been told that one of their biological parents has the surname Hall. And so we want to understand, how can clustering help them in their quest to discover who their parents are. What they believe is that they are full siblings, but they're not exactly sure. They've been given information that Hall is a surname of one of their parents. And so we want to understand, or in a research question, is Hall the surname of one of their parents? Who are their parents? Are they full siblings? And they're looking for evidence in their DNA matches that answers all of those questions. So what we're going to do, as I mentioned, is a combination of the LEEDS and color coding methods of clustering your matches. So in the list of Tina's DNA matches, which we'll see shortly, we'll locate matches who connect to Tina, which is the kit that we're going to be looking at Tina's kit. So matches between 400 and 90 cm, so below 400 and above 90. So this is a view of Tina's matches. Tina Hall is her name. Her brother there is Brian Hall. And this view is how your matches would appear if you've tested with Ancestry.com on their AncestryDNA platform, at least as of September 2021. So at the top, we see Brian is her closest match. The relationship described is full sibling. And the way that this is determined, if you look at the number here, the amount of DNA that they share is described here. It's also quantified in a percentage. And if we looked back at the chart, so I'll quickly go back. If we look at the chart, there is a delineation between how much DNA you would share with someone if they were your half sibling and your full sibling. And it looks as though Brian only would fall in that full sibling range. So that immediately answers one of our research questions. They are indeed full siblings. They have both of the same parents. And so that's helpful to understand as we look at the rest of the DNA match list. So from here, we can see that there are other DNA matches. But what we were instructed to do on the previous slide is to look for those who are between 400 and 90 cm. And as we can see, the matches here are a bit too high. See, at 1700 and still too high. So we're going to keep looking further down the page, and we see that at the top, that's 425, but below, we're in the right range. So starting with Leah Orr, we're looking at matches who are in that range that we're going to focus on. What we can also see here, and apologies, I'm probably blocking, move that. So Willie Webb at the bottom of this list has a family tree. We see there's some other trees there. There's some other useful information. We see names of some of these matches. So Leah Orr, Miss Hall, 4109. That could be a Hall relative, and other surnames as well. So there's lots of good information to look at. So what we're going to do is start with the matches who share below 400, as I mentioned, with Tina, because the goal of clustering is to identify your grandparent lines. And in some cases, that starts with your great grandparents. So matches sharing more than 400 centimorgans are going to be too close to identify and isolate certain lines that we want to find in your DNA matches. The reason that is because those closer matches share multiple lines with you. So if you consider Tina and Brian, they have the same parents, so they have all of the same ancestors. And so what we want to do is basically a process of elimination by isolating these different lines. And if you share too many lines, it's hard to do that. So now that we've located the DNA matches in the right range, we can start clustering. To do that, we're going to add that first match, Leah Orr, to a new group on AncestryDNA. So we see Leah Orr there. And we're going to add her to a group. So if you see on the right, there are these little plus symbols on AncestryDNA. If we click on that, it'll add her to a group, which opens up this new window. We haven't created a group yet, so we'll need to do that. So we'll create a custom group there. And what that does is it opens up a new window where you can first name the group. So it can be group 1, it could be, unknown 1, something, just to give us a starting point. So we're just going to name that one group 1. And there at the bottom, there's an assign a color. So if I were to click on this, I would open up different colors that I can choose from, because as I mentioned, this is a combination of the color coding method and LEEDS. So we'll save that. And now we have group 1. She still hasn't been added to it, so we would need to check that box and then add her to the group for Leah Orr. So now that Leah has been added to a new group, there is a blue dot here by Leah's, or in the line of Leah's profile there, with a new pencil next to it. That pencil is just in case I ever want to edit the groups that Leah is a part of. So now what we'll do, we'll probably get some instruction. So we've added the first match under 400 cm, so that's Leah Orr, to a new group. So what we're going to do is go to Leah Orr's profile, navigate to her shared matches, and add all of Leah's shared matches to this new group one that we've created. So we're going to walk through that. So I've now clicked on Leah Orr's profile line. It takes me to this page where I can see a comparison basically of Tina Hall and Leah Orr. So normally the family tree information would be there if Leah has a family tree. There's an ethnicity tab where I can compare the ethnicity of Tina Hall and Leah Orr. I can see Leah's in that group that we added Leah to, and now we're going to go to shared matches. So this is now the list of people who are matching both Tina and Leah. And what we're going to do is add all of them to that group one. So we click the plus symbol, opens up that side window, and we're going to check group one. So now Brian will be added. And as you can see now, there's a checkbox near everyone, and this list will be quite long. So you're going to check that box for everyone on that page, on that list. And again, it might be a long list, but that's how you're going to cluster this. And once you've checked everyone, you're going to add them to the group. And what you'll see is a blue dot next to everyone's name. That means they've been added to group one. And so essentially what you've done is created your first cluster. So now that you've added those matches, it's time to identify and add your second cluster. So what we're going to do is go back to your DNA match list, the list of all of your matches, so not the shared list we were just viewing, and you'll locate the next match after Leah Orr, who does not have a blue dot. So we're still looking in that range between 400 and 90 cm, and we've already added Leah to group one. So we're looking for the first match after Leah who is not in a group. So this is a view of our main DNA match list. If you don't know how to get back to your DNA matches, if you're on Ancestry, you can go to the top, click DNA, and then DNA matches, and it'll take you to your main list of matches. If you manage multiple kits, you'll need to select the proper kit that you want to look at. And so here is Leah. We're looking for the first match after Leah, who does not have a blue dot, and that's Miss Hall 4109. So as I mentioned before, this group is pretty interesting because it might be a Hall cluster, and we already have information that Brian and Tina, whose surnames are Hall, that their surname may be from one of their biological parents, who may also be a Hall. So we'll add Miss Hall to a new group by clicking this plus. So add to group. And we're going to create a new group. So create a custom group there. All right, so we got group 2, which we've named, but we're actually going to change that because we have a research question and hypothesis that this might be the Hall cluster for Brian and Tina. So we're going to name that Hall instead. We're going to save it. And so now Miss Hall 4109 has been added to a new group. And we're going to do the same thing. We're going to click view match, and that's going to take us to, well, actually we're going to look at some other details here. So we're going to go back to that main list, which we were just on, and we're going to click Miss Hall's profile, view match, view shared matches, and add all of those shared matches to the Hall group. So we're on the comparison page. After clicking view match, we're going to click shared matches. And so this is a list of the shared matches between Tina Hall and Miss Hall 4109. So we see Brian at the top. He is in group 1 already. We also see some new people: Felicia Bias, Benji Bias, Hall Pass 81, Ed Bias Baker, and there would probably be more listed below. We see a private tree, a public tree, unlinked tree. So that unlinked tree means that Hall Pass 81 has not linked their DNA results to their family tree that's on Ancestry. But you can still view it because it's public, it looks like. So we're going to add all of these folks to a new group. Well, not a new group, to the Hall group that we just created, including Brian. So we have the Hall group there. We clicked on the plus to open this up. We're going to check Hall, and we'll check it for everyone on the page. And so now everyone has a yellow dot because they're all in the Hall cluster. And there's a few interesting things to look at here. So one is this Hall Pass 81. So their surname possibly could be Hall. To get more info on that, we would want to look at their tree, which may have their name, their parents' names, or whomever else they've listed. We also may want to reach out to them as we learn more information. That could be someone who has some of the answers that we're seeking. They may be seeking connection as well, or may be willing to work with you. We also see 3 people with the same surname bias. And so a research question to pose with that is, 1, could these biased relatives be Halls? Maybe you share a Hall grandparent with them. What is also possible is that one of Brian and Tina's Hall parents could have a parent that has the bias surname. So that bias surname could be one of Brian and Tina's grandparent lines as well. And so to get more info on that, we'll want to look at trees, which we won't cover in this workshop. In a descendant research workshop to follow this, we'll examine how you might be able to make those sort of discoveries. So these are the things we just pointed out, just to recap. So there's a few interesting notes about the Hall Pass and possible Hall surname, and that these biased relatives who could be closely related to one another, and certainly related to Brian and Tina. And we would want to use the trees to investigate further. Basically, bias could be a subcluster of the Hall cluster. So now where we are is we're going to keep repeating that process. So we have created several clusters, 2. So one is group 1, and the second is the Hall cluster by these blue and yellow dots. And what we'd want to do next is identify the next cluster. So the person after, we're now down to Willie Webb. So we want to look beyond Willie, further down on the list, who doesn't have a dot between the 490 cm range. And by that 490 cm range, we're looking here. We're looking at this amount of shared DNA on the main list of your matches. So if there's a match after Willie above 90 cm who doesn't have a dot, we'll create another cluster and add them and their shared matches to that third group. So those 2 clusters that we created likely represent 2 out of 4, or possibly 2 out of the 8 great-grandparent lines. Again, to confirm that, we would want to look at their trees. So we'll repeat this process until we've created new clusters down to roughly the 90 cm range. So one thing to consider, and we talked about this in the disclaimers, is if you don't have a lot of close matches in that second to third cousin range, you can go down a little bit further. You can look down to about 70, 50 cms and still create new clusters within that range of matches. Also, what you'll want to do as you're clustering is make note of familiar and repeating names. So in this case, we saw that Hall was a familiar name, one that we had a little bit of context about. Also, we saw a repeating name. We saw several matches with the surname Bias, a few with the surname Hall, and we would want to keep doing that. We would also want to look at their trees because their trees may have additional repeating and familiar surnames. Again, there will be a subsequent workshop to this on descendant research and possibly some additional ones at a later time that will examine how to make these inferences and get insights looking at trees in your matches. So that is really the gist of clustering via the LEEDS and color coding method. If you want more info on the LEEDS method, you can visit danaleeds.com. That's DANALEE AncestryDNA.ds.com. Also, this presentation workshop will be shared via Kinkofa. To learn more, you can visit kinkofa.com. You can also join our community, where we'll have many other workshops and events like this where you can learn how to expand your research and also commune with others researching. So as I mentioned, next in this series, we have a workshop called Where They At? DNA Descendant Research. So in that workshop, we'll cover really what to do after you've done this clustering work. You have these groups, some of them may not be familiar or recognizable to you. And so we're going to try to make some connections with these clusters that we formed. So that is it. Thank you so much for joining, and I hope that this presentation helps your research.